Graphs at both IGCSE or GCSE and A level are marked on the same principles, which can be memorised using ALPS. That's A, which is axes labelled with units, L for the line or curve of best fit, P for points precisely plotted, yay alliteration, and S for a scale that takes up at least half of the available space. Let's go over all of these with a couple of examples. This table shows us the concentration of glucose at different distances along the small intestine, looking at how starch is digested. Note that most tables, with exceptions, will have the independent variable on the left-hand side and the dependent variable, often with the repeats and a mean, on the right. This information can be useful in answering questions, but you should also follow this convention yourself when designing tables. Let's go to our graph paper. Please don't use squared paper from IGCSE onwards, it's just not precise enough. Even this paper isn't great, but it's what I have to work with. On a graph, the independent variable, the one to the left on our table, should go on the x-axis, and the dependent variable will go on the y-axis. We'll simply copy out the titles from the table along with units. You won't get the A mark if you don't include units. In this situation, you can write mol per dm cubed in either way, using the /dm to the power of 3, or the dm to the power of -3 without the slash. Now let's choose a scale to get our plotted points to fill up at least half of the space horizontally and vertically. On the x-axis we have the points ranging from 50 to 400 cm. We've been given 6 large squares, so if we do the obvious and put 100 cm on each square, that'll take us more than halfway across, which will be enough for the S mark. On the y-axis our points go to a maximum of 487 mol per dm cubed, and the space we're given is 8 large squares high. 487 is a horrible number, but you can use it as a starting point. Let's do 487 divided by 8, which gives us 60.875. But if we said that each large square represents 60 mol per dm cubed, our y-axis will only go up to 480, and we wouldn't be able to fit that last point in. You will lose marks if you use a ruler to add it up above the graph. I don't make the rules. 60 is also not massively user-friendly in my opinion. We'll have to go for the next sensible scale up, which I would personally say is 100 mol per dm cubed. This way we could get to 800, and that means some wasted space, but it takes up just over half of what's been allocated, and that's all we need. Now that we've got a scale, let's plot the points. Note that, in general, you will be expected to use a line graph, not a bar graph or histogram at this stage, though, of course, always read the question. Use a small cross, or a dot inside a circle. Precision is important, but most exam mark schemes will allow variations of plus or minus 1 small square. So if your data is too precise for the scale you're about to use on your graph, don't worry, just get as close as you can. Of all the marking points, P is probably the most self-explanatory. Just remember to start off using pencil, as it's easy to make mistakes, as you can see in mine, where I make a number of mistakes. We're ready for the last step, the line of best fit. At this point, I do sometimes go over my pencil marks in pen, because a curve of best fit can be a bit tricky. Most people ask how to decide if you should use a line or a curve, and honestly it's just a case of looking at it and deciding if it's a straight or a curvy relationship. To reassure you, examiners will often allow a well-drawn straight line of best fit, even if a curve would be better. What they won't usually allow is a jerky dot to dot. In rare occasions they may specifically ask you to join the dots, so always read the instructions, but they definitely won't allow a feathery or arty curve like this. A straight line of best fit should always be drawn with a ruler, and must have an approximately equal number of points on either side of the line, if it can't go through all of them. You should have a clear ruler, lay it over the top of your points and see what works best. Of course I'm using my iPad and Notability, so I'm simply drawing a line and moving it around to see what works best. On paper, this is why I go over my points in pen before this stage. Excuse all the beeps. If I need to, I can rub the line of best fit out and draw it again without having to draw all the points in again. A curve of best fit also doesn't have to go through all the points, but it does have to be drawn in one smooth line freehand. Don't trust those so-called curve rulers. They do have some elasticity and will spring out of shape and drive you nuts. You will get better at this with practice and a little bit of confidence, but one thing that can really help in basic curves, not like this one unfortunately, is sliding your page around so your wrist is behaving like the point of a compass, sitting in the pivot point of the arc you're going to make with your pen. You may decide that the final point here is an anomaly, in which case circle it and ignore it when drawing the line of best fit. Or you may suggest that it's part of the overall trend and that glucose probably does start decreasing at this point. One more thing, remember that you don't have to start your scale at 0. If your points go from 50 to 80, for example, don't waste most of your graph paper by starting at 0 and going up in tens. Use the wiggly line at the bottom of your scale if you like, but it's not necessary. Simply start labelling from 50 and go up in 5s or even 2s if your space allows. Of course, graphs can be much more complex than this, but this covers the basics. Let me know if you need help on anything else and I'll see what I can do.